computers talk. After watching this video, you will be able to describe 3 widely used notational systems, convert numbers between notational systems, identify common data types, and identify the 2 most widely used character types. In computers, a notational system, also called a numeral system, is a system of symbols that represent numbers. The 3 most widely used notational systems are decimal, binary, and hexadecimal. Decimal notation is base 10, as in numbers 1 through 9, then 10, 20, 30, and so on. Decimal notation uses a decimal mark, usually a period, which identifies the numbers to the right of the period as a fractional amount. Decimals with negative values display a minus symbol immediately left of the number. Binary notation is the base system for computer speak and programming in bits, but more commonly referenced in bytes. Binary uses only 2 numbers, 0 and 1, and combinations of those 2 numbers. Binary notation represents 0 as an off state and the number 1 as an on state. A single digit is known as a bit and is the smallest piece of computing information computers process. The next size of computing information is a byte. 8 adjacent bits, or digits, create a byte. To convert decimal numbers to binary numbers, divide your starting number and each subsequent quotient by 2 until the quotient equals 0. For example, start at the top of the column with the decimal 25. Divide 25 by 2 and note the remainder. Now, divide the quotient 12 by 2 and note the remainder again. Repeat these steps until you get 0 as the quotient. For your final step, write the remainders so that the last remainder, for 1 divided by 2, is written first, followed by the other remainders reading from bottom to top. So the binary equivalent of 25 is 11001. Here's how to change a number from binary to decimal using the doubling method. Let's start with the binary number 010010. Start with the leftmost digit, which is 0. Since you are starting from the leftmost digit and there is no previous digit to the leftmost digit, we consider the double of the previous digit as 0. Double the previous number and add the result to the current digit. Continue the same process for the next digit, which is 1. Now double the previous digit and add the number to the current digit. In this example, you get 0 times 2 plus 1, which is 1. Repeat the process for each number, moving to the right 1 digit at a time. The result of converting the binary number 010010 to a decimal using the doubling method is 18. Next, the hexadecimal notation system, often shortened to hex, is made up of 16 symbols using the numbers 0 through 9 and the letters A through F to represent decimal numbers 10 through 15. Hex offers compact notation for large numbers. Hex is used for MAC addresses, which identify where the device resides on the network, similar to your home address, color values, IP addresses, which are website addresses, and memory addresses, which identify where data exists within the computer's storage. The first column displays decimal numbers from 0 to 10. The second column displays the decimal number's hex equivalent. The third column displays the decimal and the hex number's binary equivalent. In this example, reading left to right, you can see that the decimal 10 is equal to A in hex and 1010 in binary. Many websites offer conversion tables where you can quickly convert numbers to their decimal, hex, and binary equivalents. To convert a hex number such as 123A into binary, follow these steps. First, note the hex number and represent each hex digit by its binary equivalent number. Next, add insignificant zeros to the left if the binary number has less than 4 digits. For example, write the decimal 10 as 0010. Then string each of the converted binary numbers together, working from left to right. This process is called concatenation. Your fourth and final step is to discard any leading zeros at the left of the concatenated binary number. For this example, let's use the hex number 123A. Use the table to convert each hex digit in 123A to binary, adding zeros to the left of the number if necessary to make the number a 4-digit number. Then string all 4 groups of 4-digit numbers together. On the leftmost binary number, discard any leading zeros. So 0001 becomes 1. Your result is 1001, 0001, 11010, the binary equivalent of the hex number 123A. Computers follow sets of instructions to perform tasks such as calculations, word processing, and web browsing using the following data types to process and present that information. Characters represent single letters. Strings show combinations of characters. Integers display whole numbers, such as the number 8. Floats represent decimals and fractions. And Boolean values provide yes or no and true or false statements. ASCII, first published in 1963, is the American Standard Code for Information Interchange format that translates computer language into understandable text. To save on transmission costs, ASCII was originally a 7-byte system, representing 128 binary characters. The system expanded to 8 bytes, providing another 256 characters. The displayed chart shows binary, ASCII, and hex equivalent numbers. You'll find similar charts online. Unicode includes ASCII characters, characters from languages worldwide, as well as emojis. More than 95% of the world's web pages use Unicode 8-bit encoding, commonly called UTF-8. Programming languages tend to use Unicode 16-bit, referred to as UTF-16, and a few programming languages use Unicode 32-bit encoding. Unicode provides a unique hexadecimal value for each character, called code points. The default encoding format is usually shown as U plus HHHH, where the HHHH is the character's hexadecimal value. You'll find numerous conversion services online. In this video, you learned that bits and bytes are the base language of computer communications, and 8 bits equals 1 byte. MAC addresses, colors, IP addresses, and memory addresses use hexadecimal notation. Programs can read ASCII character text, strings, integers, floats,